Know that the homework was extended to tonight, so if you didn't get a chance to do it over the weekend, you should hopefully have it pretty close to being done, if not finishing it up now for tonight. So that's the sections 1 through 4. And then section 5 and 6 I have due for Friday. I'm putting it for Friday, that way it incentivizes you all to work on the homework a little bit more during the week so that you can ask questions during these. That way you're not only working on it over the weekend. And I'm going to try to make sure the homeworks are always up well in advance. So I'm going to go ahead and start putting the Chapter 7 homework up, as well as that Chapter 6 test. Make sure you look for that here pretty soon. I think I said I was going to put that due for Monday, so that'll give you about 3 days to after you finish the last bit of homework to go back and practice over it and get ready for the test. I do want to show you that even after this stuff is submitted, you can still go back and review it. So if you just go into your normal grade book here, anything that you've worked on, you can go back and hit the review button. That'll just kind of open it back up for you, and you can go back and play around. It's not going to change the score any, but even for questions that you've already completed, if you just go into it, and if, let's say, you want to try it again, there should be a button at the bottom here, similar question. So even if you do have the green check mark, you can go and do that and just redo the problem if you feel like you need to do that. Like I said, it's not going to take the check mark away, and it's not going to change your score any. Just a nice way to review, get ready for the test. Your test is going to have the same kinds of questions that you had here on the homework, but they're going to be questions that I'm making up myself, so not just questions from the book. Okay, so with all that being said, you guys do have homework due tonight, and you have homework due Friday, for those of you that are working ahead a little bit. I know, was Jeffrey, you sent me a request already, so let's look at that one. So it's in the section 6 homework, which I'm sure some of you haven't quite gotten to yet, which is okay. We'll talk through it together. So we'll do this one, and if you guys have your own question, make sure you kind of get that ready to go. So I want to get through as much as we can get through tonight before 7. All right, so on the section 6 homework, question 2, this is all about finding center of mass. All of chapter 6 is just different applications for integrals. Center of mass is one of those applications. So here we're going to be doing a center of mass on a 2-dimensional space here, like a thin plate of glass or whatever material you want it to be. So this plate is bounded by the parabola and this line. I'll go ahead and go into Desmos here and graph those two things. So it was 6x minus 2x squared and then negative 6x. All right, so it's kind of a really crummy looking shape, right? It's this area in between the upside down parabola and my diagonal blue line here. We want to find the center of mass of this area. So just going back to the question. Wrong thing. Where was it? Okay. It does say that it has a constant density. Anytime you have a constant density, you can pretty much ignore it, or you could just set it to be 1. That way it just kind of gets absorbed into the question. So I'm going to go into OneNote here and try to write this stuff up here. So just copying over the 2 equations that we have, the y equals 6x minus 2x squared, and then the y equals negative 6x. It made this kind of crazy looking shape here. The first thing that you want to decide for these questions is you want to decide whether you want to do horizontal slices for your shape or if you want to do vertical slices for your shape. I can already say that horizontal slices for this one is going to be bad because up top here, horizontal slices are going from the parabola back to itself, and then they're going from the diagonal line to the parabola. You never want to have to redefine your slices as you go. So vertical slices are going to be the way to go for this question because I'm always going from the diagonal line up to the parabola for my slice. Another thing that we're going to need is we're going to need to know the midpoint of each of the slices. You can think of that as the center of mass of that particular slice. All right, when you're starting these center of mass questions, there's three things that you need to write down first. The dm, which is the differential of the mass, the x wiggle, and the y wiggle. All right, so I know some of you haven't quite gotten to this, so I'm trying to explain it kind of slow here. The dm, that represents the differential of the mass. That is the mass of just one of these slices. To find the mass of the slice, you're going to take the density of the slice, which remember we're just going to let to be 1, times the area of the slice. So if my density is 1, I can just ignore that. All I really need is the area of this individual slice. Remember that this was on the xy plane? Something like that. I think the intersection was at the origin here. So my particular slices are going to be located at x as I go along the x-axis. The length of my slices, or the height of my slices, is going from the diagonal line up to the parabola. So because the parabola is on top, that one's going to go first. So it's going to be that height 6x minus 2x squared minus the bottom, which is the negative 6x. You do have to be a little bit careful here because you are going to have to distribute that minus sign. So again, this whole bracket here is the height of my slice. Okay. The width of the slice we get just by taking the little infinitesimally small width, which is the dx. So that's always going to be in these questions. Just to simplify this down a little bit, we have a 6x. This is going to end up being a positive 6x, so 12x. And then we have the minus 2x squared, and then the dx on the outside still. Okay, so that is the dm. I'm going to come down a little bit and find the x wiggle and the y wiggle. The x wiggle, y wiggle is the coordinate of the midpoint of the slices that you're making. If your slice is located at x as we move horizontally across my region, then the x wiggle is just going to be x. The y wiggle is a little bit more difficult. The y wiggle is going to be the y value of this midpoint as we move across our region. To find midpoints, you're going to take the top value and the bottom value, add them together, and divide by 2. The top value is the parabola, that's the 6x minus 2x squared, plus the top value is, the bottom value is the line, negative 6x. You're going to add those together and divide by 2 to find the midpoint. To simplify this down, the 6x and the negative 6x cancel out. We have the negative 2x squared divided by the 2, which just leaves us that my y wiggle is negative x squared. Okay, so again, I know I've thrown a lot at you guys here. These questions here in section 6 have a lot to them, but once you have the dm, the x wiggle, and the y wiggle set up, everything else is just formulas. Is there any questions about how I found these three things? The dm, the x wiggle, and the y wiggle. I think I scared half the class away. Okay, now that we have those, this is now where you want to look at the formula sheet, and there's 3 different integrals that you want to do. You want to find the total mass, which you get by integrating over just the dm. You want to find the moment about the y-axis, which you get by integrating over x wiggle dm, and then the moment about the x-axis, which you get by integrating over y wiggle dm. So just plug in those 3 things that you found into these 3 equations. For the total mass, it's going to be the integral over that dm value, where the dm value was this thing, the 12x minus 2x squared. the limits of the integral comes from the locations of your slices. My slices are going to start at 0, and they're going to end wherever this intersection point is. So you can either use Desmos to find that, or just set the two equations equal to each other. So it looks like they're intersecting here at 6. So we're going to be integrating from 0 to 6. All right, and then just the antiderivative stuff now. So 12x is going to go to 6x squared. Negative 2x squared is going to go to negative 2/3 x cubed, evaluated from 0 to 6. So if I plug 6 into this, get some calculator stuff going on. Oh, my calculator like died on me now. All right, so 6 cubed, that's 216, and that's going to be minus 216 times 2/3, which is 144. And then 216 minus the 144, 72. Okay, and this has a physical meaning to it, right? Remember, this was the total mass. If you were to take this object that you have and actually weigh it, it would have a weight or a mass of 72, whatever units it is that you're using. Okay, and then just real quick, we'll do the moments. So the first one here is the moment sub y, which we get by integrating over x wiggle dm. Well, x wiggle, remember from up top here, was just x. So we're going to be integrating from 0 to 6 of x times the dm, where the dm was this 12x minus 2x squared. Distribute the x into the parentheses here. And then do the antiderivative. Evaluate it from 0 to 6. You need another calculator stuff going on. So plugging 6 into this first one, we get 864, minus plugging 6 into this other one, 648. Subtracting these two things, it's 216. Okay, so that's the moment sub y. We would also want to do the moments of x, but I'm kind of bored at this point, and I'm ready to do a different question. So the moments of x, that would be integrating over y wiggle dm. Well, remember, y wiggle was negative x squared. So it's going to be that negative x squared times the dm, which remember was 12x minus 2x squared dx. So I'm just going to dot, dot, dot. That comes out to be something. I don't really care. I'm bored of this question. The last little step is going to be finding the x bar and the y bar. The x bar and the y bar actually represent the center of mass themselves, and there's formula to these. The x bar is the moment sub y divided by the total mass. So that would be the moment sub y, which was the 216, divided by the total mass, which if you remember from the other integral was 72. And then 216 divided by 72 is something. 3. Good. So what that says, right, is that the center of mass of this object has an x value located at 3. So if my intersection point was here at 6, then we're at about the halfway point here at 3. We would just need to figure out what the y value is by finding the moments of x. The center of mass is somewhere like there for the object. Okay, so without actually doing this last integral here, it's not hard, it's just time consuming. And also, I understand that some of you haven't quite gotten to section 6 yet. Is that all right? Is there any questions? Just to prove that the x value really is 3, if I just get this wrong a few times. to see what the actual center of mass is, it's here. My x value is 3, which is what we had found. My y value would be negative 54/5. Yeah? Okay? Questions? Concerns?
Is the y value, is it just like, just using the mx? You didn't write that one down.
Yeah, it's taking that m sub x, the moment sub x, and dividing that by the total mass. Okay. So whatever this integral comes out to be, it's whatever that answer is divided by 72. That's going to give you the negative 54/5.
Okay. Alright, cool. Thank you.
You're welcome. Anybody else? Any other questions about this particular homework question before we move on to a different one? Okay, let's try something different. What you guys got? Anybody else have a homework question you want to look through?
I have one.
Okay.
In section 3, 4, or section 3 and 4.
Yep.
Number 11.
Okay. Cool. All right, so find the lateral side surface area of the cone generated by revolving the line segment y equals 2/5 x from 0 to 6 about the x-axis. Okay, so let's first look at the graph for this thing. We're taking the line y equals 2/5 x from 0 to 6, I think it said. Yep, and we're rotating this about the x-axis, so we do have to be a little bit careful about which axis we're rotating this around. Just to graph this, y equals 2/5 x is going to be a diagonal line that has a slope of 2/5. So, you know, over 2, up 5, and so on and so forth. Or add that backwards. Up 2 over 5, sorry. Up 2 over 5 for the slope. But we're going out to 6, which is out here somewhere. And we're going to be taking this region and then revolving that around the x-axis this way to make a cone kind of on its side. Okay. Great. So to do that, first let's talk about our surface area formula. There's really two different formulas, and it depends on whether you're integrating along the x's or integrating along the y's. We're going to be integrating along the x-axis here just because of the way we're doing our revolution. And that formula is 2 pi y square root of 1 plus the derivative of the function squared dx. You definitely do not have to have this formula memorized. It's on the formula sheet, and I think it's written down in two different ways. Sometimes I have the y written here. Sometimes I just have this written as f of x, but just know it's the same thing. Okay, so to do this, now we just take the y value and we plug it in to our function. We do need to have the derivative of this first, but the derivative is just that constant, just the 2/5. So I'll go ahead and plug it in as is. So our integral is going from 0 to 6, just because that's where we're stopping here on the x-axis. The 2 and the pi are just going to stay there. My y value has to be in terms of x, so we're going to be plugging in our function here, 2/5 x, times the square root of 1 plus the derivative of our function, which is just that constant 2/5, all squared. Okay, simplifying out these constants, we have a 2 and a 2/5, which is 4/5, and the pi. All of that we can take out of the integral. So the 4/5 and the pi comes out of the integral. All we have left from the front here is just x. And then the square root, 2/5 squared is 4/25. And then adding 1 and 4/25 together, you can just do that in the calculator, but it's 29/25. Here you can take the square root of the top and the bottom separately, and then that itself is a constant that'll come out. So in the front here, I still have the 4 in the numerator, and I'm going to include onto that a square root 29 and the pi. In my denominator, though, I already had a 5, but now I'm going to be multiplying by another 5, so I'm going to have a 25 down here. And then all that's left over from my integral, the only thing that's not a constant is that x. So I'm just going to be integrating from 0 to 6 over x. That has antiderivative of 1/2 x squared. That going from 0 to 6. If I plug 6 into this, I get 36 cut in half, which is 18. Don't need to worry about plugging the 0 into it. So now it's going to be this constant out in front times the 18, and then whatever that is. I don't think it simplifies down very well. I think all you can do is multiply the 4 and the 18 together, which is 72. So here we're going to get 72, the square root of 29, the pi, all divided by 25. And I hope that's the right answer. Let's type it in and see. So 72 square root of 29, the pi, all divided by 25. Well, it wrote funny, but it'll count it right. So comparing this question to the last question, at least it's a little bit faster. It's not any easier because this formula is pretty awful looking. And then one other thing that I do want to mention here is that it says the lateral side of the surface area. When you're talking about an object, the lateral side means everything except for the base. So for this cone that we're creating, we're ignoring the circle base that we would have on the end here. We're just talking about the folded side that we get from rotating this diagonal line around the x-axis. But is that one all right? Does that make sense? Any questions about going through that one? Is there any other homework questions that anybody has?
Can you go over number 12 from 6.3?
Sure can. Okay. So number 12 here, find the area of the surface generated by revolving x equals 2 square root 9 minus y from 0 to 8 about the y-axis. And it gives us a picture for this one, which is kind of nice. So we're taking this blue line here, which is our function, and then revolving that around the y-axis. So here you have to be a little bit careful because this time when you're finding surface area, we need to use the other formula, the formula that is integrating in terms of y's instead of integrating in terms of x's. It's the same formula, just a little bit backwards. So it's still the integral of 2 pi. Instead of the y value being here, now it's the x value, and then the square root of the function of 1 plus the function in terms of y squared dy. I think I might have a g here instead of an f, but it's the same stuff, right? 2 pi, the x, which is a function of y, and then the square root of 1 plus the derivative with respect to y squared dy. Okay, so we're just plugging that in for what they give us here. So before I write this in to the integral, let's go ahead and find the derivative of my function here, treating x to be my f of y. So that's 2 square root 9 minus y, but I'm going to think of that as 2 and then that 9 minus y to the 1/2 power. We're going to bring down the 1/2 power using the chain rule. Then the 1/2 and the 2 cancel out. We're going to leave the inside alone, and we're going to take 1 away from the exponent, but we also have to multiply by the derivative of the inside. All right, so it may have been a little while since you guys have done a derivative chain rule, but it's the derivative of the outside, which is bringing the 1/2 down and then taking the exponent to negative 1/2, times the derivative of the inside. The derivative of the inside is that negative 1. We can rewrite this to make it look a little bit nicer by moving the exponent down to the bottom, So we are going to still have the negative 1 up top, but now we have a 9 minus y to the 1/2 in the bottom, which is the same thing as the square root 9 minus y. All right, so here's my derivative. That I'm going to be plugging into my integral here. So now my surface area is going to be the integral of the 2 pi. X needs to be written as a function of y, so I'm just going to grab our formula there, 2 square root 9 minus y, and replace that with the x in the integral. That times the square root of 1 plus the derivative squared, which is this thing, negative 1 over the square root of 9 minus y, all squared. All right, I know that's kind of, my handwriting's kind of gross there. If anything's confusing, just let me know and I'll try to rewrite it a little bit neater. Oh, the limits, right? The limits are going from 0 to 8. I mean, they tell you what the limits are in the question. Pulling the constants out, so we have 2 2's, which is 4, and then the pi. So I'm going to pull a 4 pi out. We have the integral from 0 to 8. And just to write it all out, we still have this first square root of 9 minus y. But then this bigger square root, once I square that derivative off, I still have the 1 out in front, plus negative 1 squared is positive 1. And then the square root in the denominator, when I square that, it just becomes the regular function 9 minus y. Okay. I'm sure for most of you, when you're doing this question, maybe you made it to here, and then you got stuck. And I would be stuck here too, but there's a little trick to it. The trick is anytime you have 2 square roots like this that are multiplied together, you can go ahead and just multiply the insides of the square root. What that means is we're going to take this 9 minus y here from the first square root and distribute it into the 1 and then into the other fraction, 1 over 9 minus y. Okay, so we still have the 4 pi out in front, still have the integral from 0 to 8, but now we're just going to have 1 square root of multiplying these two things together. So we have the 9 minus y times the 1, which is 9 minus y, plus we're going to have the 9 minus y times this fraction, which just cancels each other out, and we're left with the 1 there from the numerator. Just rewriting everything down, combining the 9 and the positive 1, we're going to have a 10 minus y now inside of that square root. Okay, at this point, you're going to be doing a u substitution. So we'll let u be the inside of the square root, 10 minus y, and then du would be the differential of this, which is negative dy. That negative sign, I'll just move out to the front of my integral. So I'll rewrite this as negative 4 pi. The integral, I don't know what the limits are now because I'm changing over to u's. When I do plug u into the square root, I'm going to write it as u to the 1/2 power. It makes it a little bit easier for me to do the antiderivative in my head. Okay, and then again, that negative sign that I put out in front, that's coming from the differential here. Antiderivative of u to the 1/2 is we're going to raise that 1/2 up to 3/2 and then divide by that. So we're going to get 2/3 u to the 3/2. And now I can substitute back in what u is equal to and then multiply the constants that are out in front. Negative 4 and 2/3 are going to multiply out to be negative 8/3. Still have the pi. The u was 10 minus y to the 3/2 evaluated between 0 and 8. And now just plug in your limits. If I plug 8 into the y, I have 10 minus 8, which is 2. 2 to the 3/2 is nothing nice. So if I plug 8 into here, I still have the negative 8/3 pi, but then this comes out to be 2 to the 3/2, and I would just leave it like that. You could write this as 2 root 2 if you really wanted to. So that's going to be minus, plugging 0 into this. That's going to give us 10 to the 3 halves, which is equally not as nice. I think what the book does for the answer here is that they factor out an 8/3 pi from these two things. So we're going to have an 8/3 pi out in front, and then we're going to have this negative 2 to the 3 halves, or negative 2 root 2. This double negative makes this positive 10 to the 3 halves. And I would probably just write it like this on the homeworks. Trying to get both on the same screen at once. Well, let me type it in just to make sure it's right, and then I'll go back to my written up stuff here. So the 8/3 pi, negative 2 to the 3 halves, and then plus 10 to the 3 halves. Okay, great. Yeah, so a little bit more difficult than the last problem, but it just comes down to that trick. And that trick is multiplying the square roots together by distributing the first square root into the second one.
Thank you.
You're welcome. Okay, good. Anything else? Any other homework questions you guys want to look at?
Look at number 7 from that same chapter.
Sure can. All right, so number 7 here, find the arc length function for the graph f of x is 4x to the 3 halves using 0, 0 as the starting point. And then what is the length of the curve from 0, 0 to 432? Okay, yeah, so this question is not something that I talked about in the videos, but they did talk about it a little bit in the book. I think it's fascinating. I think these kinds of questions are really cool, and I hope it shows you just how powerful calculus can be beyond what we're doing here in the classroom. Taking what we are learning in the classroom and just taking that one little step further. So I'll kind of to slowly explain what this question's doing and help you out with doing the question. So we're given our function 4x to the 3 halves. It doesn't really matter what this function looks like. Just know that it's a line, right? Some kind of curve out in space that intersects at 0, 0. What we want to do is that we don't want to just find an arc length from 0 to some other location. Let's figure out if we can find a formula for the arc length from 0 to anywhere that we could possibly need it. The way we're going to do that is we're going to come up with our own function, the arc length formula, based on the arc length definition that we have in integral form. So just to remind you, I'm going to get away from the homework here. Just to remind you, the arc length is the integral over that square root of 1 plus the derivative squared. What we're going to do to get kind of clever is that we're going to integrate over this over a dummy variable, and we're going to be using some of the fundamental theorems of calculus. First thing we're going to need is we are going to need the derivative of our function. So that's just going to be bringing down the 3 halves. 3 halves multiplied by 4 is 6. Taking 1 away from the exponent. And then plugging that in. Now when we plug that in, we're going to be plugging it in so that it stays a function of x. Which means that our arc length over here is still going to be an integral. Starting at the point 0. But it's going to be going to just x. Like we don't have a certain stop point for it yet. It's just going to be going to wherever we want it to go eventually. Copying down the rest of the formula, it's the square root of 1 plus this thing's derivative, 6x to the 1 half. Now here's a little bit of a problem. We already have an x in the formula since that's what we want our arc length to be in terms of. So we have to come up with another variable to integrate out, and that's what we call a dummy variable in calculus. So instead of putting an x into here, we're going to be integrating over the dummy variable. I think the book uses tau, which is like a funny looking t. So we're going to plug in 6 tau to the 1/2 all squared, d tau. Think of that as just a dummy variable. It's really representing x, but I can't use x because I already have x used as one of the limits of my integral. Just to finish off the integral here, when we square that, 6 tau to the 1/2 squared is going to be 36 tau, d tau. You could just put t there instead of the tau if you really wanted to. I'm just trying to use the same notation the book uses. Then to do this integral here, it's another u substitution. So we're going to let u be that 1 plus 36 tau, and then du would just be 36 d tau. So what I'm going to do is I'm going to divide by 36 on both sides here. And then the d tau I'm going to replace with 1 over 36 du. So now my integral has different limits, doesn't matter what they are. I have a u to the 1/2 when I replace this with u, and now my d tau is 1 over 36 du. That 1 over 36 I could just pull out to the front. The antiderivative of u to the 1/2 is 2/3 u to the 3/2. And now I can replace back in my substitution. U, remember, was 1 plus 36 tau, and then it's going to be that to the 3/2. This now we're going from 0 to x. Okay, so I know I did a lot there pretty quickly, but it was just a u substitution. We have our integral of the square root of 1 plus 36 tau. We do our u substitution. We end up with our antiderivative. I'm going to clean up this antiderivative a little bit by multiplying the 1/3 for 36 and the 2/3 together. So that's something. 1 over 54, I think, is what that would come out to be. All right, now we're going to plug in the x in for my tau minus plugging the 0 in for the tau. If I replace the tau with x, it's just the same thing. So I have the 1 over 54. I have the 1 plus 36x now to the 3/2. And that's going to be minus plugging the 0 in for the tau. That makes this term go away, and we just have 1 to the 3/2, which is still just 1. And then we're left with the 1 over 54. Okay. So let's type this into the homeworks to make sure that we're right, and then I'll kind of explain what it was that we just found. So just going back over to the homeworks here, and I'll try again to get everything on one or on the same screen. So first thing they wanted us to do in the homeworks was actually set up this integral. That was the integral from 0 to x of that square root of, oh, they use t, they don't even use tau. Like, I was trying to be fancy for nothing. So remember, that was that initial integral we had to do from 0 to x, and then that square root of 1 plus 36t. Then the, oh, now they want us to actually just do the length from 0 to 4. What is really cool about this answer that we just got is that I do not have to redo this integral every single time. Now that I have this formula gives me the arc length for any x value. Here we want to know the arc length from 0 to the x value 4. So instead of doing an integral, I can just plug 4 into this formula and get the answer. I'm going to have to use a calculator here because the numbers are too big. So that's going to be 36 times the 4, whatever that is, plus the 1, whatever that is, to the 3/2. So that's going to be 145 to the 3/2 over 54 145 to the 3/2. I think I'm doing that right. Divided by the 54, that minus the 1 over 54. So it's kind of an ugly looking answer, but I promise you it's the right answer. If I wanted to go further, so instead of just finding the arc length from 0 to 4, if I wanted to find the arc length from 0 to 6, then I would just plug 6 into this formula, instead of having to redo the integral all over again. Okay, I hope that was kind of cool, and I definitely hope that helped you answer this homework question. That one was a pretty hard one. Is that all right? Is there any questions about going through this one? Great. Any other homework questions you guys want to look at? There's still a lot. Oops. I think the section 5 stuff is kind of hard. I'm sure most of you haven't gotten there yet. You're just trying to get the stuff that's due tonight. But I would recommend working through some of the section 5 stuff on your own, especially if you're going to try to come to that meeting on Thursday. That way you can ask questions there. Any last questions about the homework due tonight, though? The sections 1 through 4? Do we all feel pretty good about it now? Better, worse? All right, last call. I'm going to give it another 30 seconds. Anybody else have any other homework questions you guys want to look at? What's that?
I had one from 6-6.
Okay. What you got?
Wasn't understanding number 5 too well.
Okay. Yeah, I'll look at that one real quick. So this is going to be another center of mass question. So for this one, it's asking us to find the centroid. The centroid just means the center of mass whenever you have a constant density, just a fancy name for it. So we're finding the center of mass of the thin plate between the functions x squared and x plus 6. And then they're asking us to use these equations below. What these equations do is they take that whole process that I did before, and it just makes it really easy. You can only use these formulas whenever you are between two functions, which is not always going to be the case. But if you are between two functions, you can just plug them into these integrals and just get the answer right away. So let's look at it using these formulas that they give us here. We'll just do one at a time. So let's look at the x bar first. It says to find x bar, what you can do is do 1 divided by the total mass, integral from a to b of the density, the x times the function x minus the function g. Okay, there's a couple of things that we need to do before we actually do this integral here. First thing is we should probably graph our two functions so we can figure out what the limits are going to be. We're going from x squared to x plus 6. X squared is the parabola. X plus 6 is going to be the diagonal line that intersects the y-axis at 6. So it does something like that. So this is my area in between these two things. If I want to figure out the limits to the integral, I'd have to figure out where these two intersection points are. There's a couple different ways to do it. I think a way that we haven't done that I always say you could do would be setting the two functions equal. So that'd be setting the parabola x squared equal to the diagonal line x plus 6. This is a quadratic equation, so we would move everything over to one side, set it equal to 0. Hopefully you can factor, but if you can't factor, then you can always do quadratic formula. This can factor, though, into x minus 3 and x plus 2, which gives us positive 3 and negative 2. That says that this intersection point is at negative 2. This intersection point has to be positive 3. That's going to be the limits of my integral. The other thing that we would need is we would need to find the total mass before I can actually write the stuff in. That, unfortunately, you would still have to do the same way as before. So we're going to be doing these vertical slices. And then to find the total mass, remember you're integrating over that dm, where the dm is the differential of your slices, or the mass of your slices. That's going to be the integral from negative 2 to 3. Because they're asking us to find the centroid here, we're just going to set my density to be equal to 1. So we're going to ignore the density. But the dm value then would be 1 times the area. The area would be the height times the width, which would just be that dx. The height we would get by taking the top function x plus 6 and subtracting the bottom function x squared. Right? That would give us the total distance from the diagonal line down to the parabola. The dx represents the width, so we get our total area here when we integrate. All right, so just to do this, none of this stuff can combine together, so we're just going to have to do all of the antiderivative separately. X goes to 1/2 x squared, 6 is going to go to 6x, negative x squared goes to negative 1/3 x cubed, and that's from negative 2 to 3. Take your time plugging the limits into big ones like this. I'm not going to take my time though. If I plug 3 in, that gives me 9/2 for this one. 3 times 6 is 18. 3 cubed is 27, divided by 3 is 9. Minus plugging negative 2 into all of this stuff. That's going to give us a negative 2 there, a negative 12, and then a positive 8/3 for the last one. Okay, and then trying our best to get all of these coefficients, or these constants all added together correctly. All right, so that's 9 plus 9/2 is 27/2. I think it's going to be negative 14, 42. I think this comes out to be positive 34/3. All right, I hope any of you guys have a calculator. Can somebody type all that in for me and actually get a number? My calculator's dead. I guess I could try Google. All right, whatever 24.83333 is.
I did it. I think it is right.
Okay. What's that as a fraction, though?
Like I'm saying, like the thing that you just scratched out, I think that was right.
Oh, okay. Well, what happens when you add these two things together?
Hold on one second.
Okay.
It's 149/6.
Perfect. Okay, so that's the total mass. So that goes out in front as a reciprocal. Now we can do the whole integral here. Okay, we have all the prep work done. Now for the actual integral itself. So my x bar is going to be 1 over this mass, which is the reciprocal. So instead of 149/6, we're going to do 6 over 149. Integral from a to b, which is the negative 2 to 3. My density, which is just 1, times x times my function f of x. It gives it here, f of x was just that x plus 6, minus the function g, which was the parabola x squared. Okay. Copying the constant down, distributing the x into all of this, we get x squared plus 6x minus x cubed. None of those will combine, so we're just going to do antiderivatives for all of that. So we still have the 6 over 149 out in front, but then x squared goes to 1/3 x cubed, 6x would go to 3x squared, negative x to the third would go to negative 1/4 x to the fourth. That's from negative 2 to 3. And then again, I would have to have a calculator. There's no way I can plug this stuff in on my head. So you would plug 3 into all of these different x values, minus plugging negative 2 into all of these different x values. And it gives you a number. I have to charge my calculators. Trying to get clever here with Google. This is going to take too long. I got this. Whatever that is as a fraction. Oh, maybe not. It says that it canceled out some of my stuff because it was too long. Well, anyway, I hope you guys can plug numbers in. But that's it. Whatever this comes out to be, that is the x bar. Like, that is the center of mass for x. Now, that's just one of them. You would still have to do this integral as well to find the y bar. It shouldn't be too much more difficult to do this one, now that we've done all the prefix stuff. The reason that I don't really like this is because I think we just did as much work as just doing it the other way. So I think doing it the other way is a lot simpler than using these formulas. But if you like using these formulas, then by all means, feel free to use them. Did anybody figure out what this actually comes out to be? Without me cheating and just looking at the answer. Yeah, is anybody working on it? Otherwise, I'm going to give up on it. I'll just type in the answer wrong a few times until it says what it actually is. Yeah, so it should come out to be 1/2. So is that all right? Questions? Concerns? You're welcome. So I know I didn't do the other one, but I promise that the other one is the same thing. Now that you have the total mass, you just plug the stuff into the integral and then square off the functions, subtract them, and then integrate over it. It's going to be another polynomial, and again, the numbers are just going to be really big. Hard to do by hand. So if you have a calculator, just use that calculator then to find the integral for these things. Okay, it's getting kind of late, like it's almost 7. Is there any last questions before we go here? Keep working on this chapter 6 homework here. You have the 2 homeworks that are due tonight and then the 2 that are due for Friday, the section 5 and section 6 stuff. I may end up pushing things back and then moving the test back just because I know that the stuff was down over this weekend and a lot of you have jobs like during the week, so you can only work on this stuff really over the weekend some. I'll think about that and kind of see what to do. But the test itself, I still think I'm going to have the test due for that Monday, just because it's the summer and we got to get through this stuff so we can move on to chapter 8. But these homeworks, maybe I'll just have them due for Sunday and just kind of keep Sunday as the normal for the homeworks. For the chapter 6 tests, just so I don't get a whole bunch of emails about it. I did send off that email this morning. I hope you read through that. But for the test, you can use your notes. You can use the formula sheets, of course. You can use the book. What I don't want you guys doing, of course, is using each other or using any other person. But you can use all of your resources that you have available to you as normal. Your book and your notes and, of course, calculator and that kind of stuff. There is going to be a time limit on the test. I think the test is going to be about 10 or so questions, and there's going to be a 3-hour time limit, which should be plenty of time to do 10 questions, including looking stuff up if you need to look stuff up. And then don't forget that as you're working on it, also write out your Scratch work and then submit your Scratch paper into Moodle if you want partial credit for questions that you may make a mistake on. Okay, but I'm calling it here for the day then. Thursday at 1, we're going to be doing another one of these. So as you continue working on the homework, write down ones that you're struggling with, and we can look at those on Thursday. Other than that, hope you guys have a good night. Hopefully see you on Thursday. Bye. Bye.
Good night.
Get out of here. Good night.